Well, welcome back from break, gentlemen. And today we're going to discuss ratios and proportions. Why doesn't ratio rhyme with patio? Will someone explain that to me? So what are ratios? Well, a ratio is just a comparison of two quantities using division. You've been using ratios since grammar school because basically all fractions are ratios. So we can express the ratio of quantities A and B as the following. You could say A to B, A colon B, which is read as A to B, A over B, and B can never be equal to zero. A ratio can never have zero in the denominator. Um, it's like saying, hey, I ate 3/0 of pizza. I had 3 slices of no pizza. That doesn't happen, right? So we always express ratios in simplest form. Extended ratios now are ratios which compare three or more values. Okay, so the expression A to B to C means the ratio of the two values is A to B. The ratio of the second two values is B to C, and the ratio of the first and last values is A to C. A to B to C is really a very helpful uh, ratio, extended ratio. We use that all the time in solving angles of triangles, right? The angles of the three angles of a triangle are, you know, in the ratio of 3 to 5 to 7. What is the measurement of each angle? So that's pretty much, we've been doing that already. So this should be somewhat of a review. There we go. This may make more sense if I write this in this format here. So if I say A, and then I go like this, colon, here's my colon. Let's try this again. A to B equals C to D. So the extremes are out here. The means are in here. So that's another way of remembering it. When you write it in that format, the means are in the inside, and the extremes are on the outside. So the product of the extremes, AD, and the product of the means, BC, are called cross products. So basically what we're saying is that when we cross multiply, we should end up with equal values. So in a proportion, the product of the extremes equals the product of the means. If A over B equals C over D, when B does not equal 0 and D does not equal 0, then AD equals BC. And this is fairly simple to illustrate. If I have, let's say I've got 3/4 is equal to 9/12. Well, if I go and I do my cross multiplication, I get 36 equals 36. And I can do this with any ratio or any proportion, basically. Now, to prove this, we would do some number theory, and I can go through a long drawn out proof, or we can basically just say, hey, look, this is what it is, okay? And that's what we're going to go with to save time. Oh, by the way, this is called the means extremes products theorem. So instead of saying theorem 59, this is the means extreme product theorem. And you're going to use this in a proof, and we'll be doing some of those later. Okay, So this is called the means extremes ratio theorem, and it's just going the other direction with it. Basically what it says is, hey, if I've got these two products, and let's take a look at something such as this. Let's say I know that 20 equals 20. So I can pick two factors, okay, of 20, and I can say, well, let's go with 2 and 10 over here, and that's going to be equal to, let's say, 4 and 5 right here, correct? Well, if you remember, it's AD times BC, right? So if I take those and I put them back in this format right here, I can end up with is 2 over 4 equals 5 over 10. Ooh, it's like magic. With some of you, it sort of is like magic because you're probably confused and going, ooh, how does this work? Well, take a look here. Just go through the process I just did. Anyway, yeah, I miss you guys, and I haven't been able to give you a hard time in a while. Can you tell? Let's move on. So equivalent proportions. The following proportions are considered equivalent. So if A over B equals C over D, then we can flip them over. You'll see here that basically these have just flipped, right? We just flip these over. And no matter what, I'm still going to end up with AD equals BC over here. And this one here, again, we switched B and C, those two switched. But when I do my cross multiplying, I still end up with AD equals BC. With this final one here, I've done both of these, right? I've switched A and D, I flipped them, and then I switched them. So I've got A and D here like this still, right? AD is still equal to BC when I multiply. All right, so I flipped and then I switched. So those are still all equivalent. How do we know? But when we get the equal products. All right, now this is a concept that a lot of people get stuck with, but it's really not as difficult as you might think. In a mean proportion, the means are the same, okay, and they call this the geometric mean. So if the means are equal, either mean is called a geometric mean or mean proportional between the extremes. So if you look here, 1 over 4 equals 4 over 16. Or we have another example with all variables. A over x equals x over r. So those are geometric means, okay? Because when we cross multiply, we're going to end up, in this situation, we're going to end up with x squared equals AR. So we're going to end up with, and this is why it's a geometric mean as opposed to an arithmetic mean. An arithmetic mean is your average. Okay, so when we have an arithmetic mean, that is when we are adding up numbers and dividing by the number of terms we added together. A geometric mean, we end up with this situation right here, x squared equals AR. All right, so the arithmetic mean, the average of two numbers, is another kind of mean between the numbers. That's called the arithmetic mean, right? Add the two numbers, divide by 2. Geometric mean, cross multiply, end up with a square. Okay, so here's some problems. Okay, So as you can see here, finding the arithmetic mean, you just basically add the two numbers together, 3 plus 27 divided by 2, and get 15. If we're doing a geometric mean, what we're going to do is set up a proportion where the extremes are 3 and 27. We're looking for a geometric mean, so the x goes under the 3 and above the 27. So we cross multiply, get x squared equals 81, and then take the square root of each side. X is equal to either positive or negative 9. Let's insert some awesome example problems here. Find the fourth term, sometimes called the fourth proportional over proportion, if the first three terms are 2, 3, and 4. So the fourth term is if A, so if we remember we had A over B equals C over D. Well, the way they are naming these, this is first, this is second, this is third, and this is fourth. So if we're looking for the fourth term in A of a proportion, okay, we're going to end up with 2 over 3 equals 4 over, and I'm going to use the letter D here. So now we can go ahead and simply cross multiply and solve for D. So 2D is equal to 12. Therefore, D is equal to 6. So the fourth proportional, or the fourth term of a proportion, in this case is 6. So your answer is 6. Find the mean proportionals between 4 and 16. Well, again, the mean proportion is a geometric mean, right? The geometric mean is the mean proportional, right? So 4 and 16, 4 over x equals x over 16. So we're going to cross multiply here, and I end up with x squared equals 64. So I'm going to take the square root of each side, and I end up with x is equal to plus or minus 8. Okay, this is a type of problem that gives a lot of guys fits. And it's really not as hard as you might think. So we know that we're going to end up with, we want to get these products where x and y are the ratio. So we want to find the ratio of x to y. So 3x equals 4y. Now the ratio of x to y is going to look like this here. So we want to get this with x over y. Well, to get x by itself, I have to divide each side by 3. To get y under the x, I have to divide each side by y. So if you can see what I've done here, you can now cancel. These 3's are going to cancel. These y's are going to cancel. So now I know that x over y, the ratio of x to y is equal to 4 over 3. And the way you can check your work is, we'll come over here, I'll do this in a little different color, and I'm going to say x over y is equal to 4 over 3. Well, we can check our work by cross multiplying, can't we? We can cross multiply like that. So I end up with 3x equals 4y, and lo and behold, isn't that our given problem? So this is our final answer. So 4/3 is the ratio of x to y. Okay, is x over y equals a over b equivalent to x minus 2y over y equals a minus 2b over b? Well, the way we would do that is we're going to take each of these and separate these out and see if we get the same when we cross multiply. So over here, this one is equal to bx equals ay. Now, if when I do this problem here on the right, this part here, if I get the same results when I cross multiply, then these two are equivalent. So let's go ahead and do that. So b times x minus 2y equals y times a minus 2b. So I end up with distributive property bx. Oh boy, that didn't come out good there. Yeah. All right. bx minus 2by. Why isn't this doing this properly? Oy, look at that. 2by equals ay minus 2by. Well, if I add 2by to each side of these, I'll get rid of them. And I end up with bx equals ay. So this is equivalent. So that's a lot of algebra. You guys all missed the algebra. I bet you're sorry you said you missed algebra now. Okay, show that a over b equals c over d, and that a plus b over b equals c plus d over d are equivalent proportions. So again, we do the same thing. We cross multiply. So when I do my cross multiplication over here, I've got AD equals BC. And we're going to come over to this other side over here, and we're going to do the cross multiplying here. I'm going to multiply this one and this one. So D times A plus B is equal to B times C plus D. So I end up, when I distribute now, remember when we do distribute, we have to distribute to everything inside. Do not forget this. This is basic stuff. So AD plus BD equals BC plus BD. Oh, look at that. That looks familiar. So we're going to subtract BD from each side. And I end up with AD equals BC. Oh, wait a minute. Look at that. Equivalent. Hooray! Oh man, I've got to assign an incredible homework assignment. Okay, so that will be posted on the Google Classroom, as is always. And we'll have a little class meeting scheduled, and we'll have a homework quiz. So we'll be able to meet on Tuesday and get together and visit. I'm going to push you a little bit going forward because we are behind and times being what they are. So tomorrow we're going to meet for a homework quiz. We'll go over the homework, and then I'm going to have a presentation for you to do and another assignment to do on Tuesday. So we're pushing a little bit. I hope you're staying healthy. I hope you had a enjoyable break, but we got to hit the ground running, boys. So until the next time.
That's all, folks.
Drop the mic.